Hello. So in this video, we have to solve this equation which is represented here. Before we start solving this equation, if you are beginner to the absolute value problems, then there is another problem which I have put in the description. Please see that problem before viewing this problem. With that, let's get started. So when we have to solve these kind of problems, the first thing which we have to do is we have to find critical points. So what are the critical points? Critical points are the points where the absolute value, okay, uh, the inside of the absolute value. So for example, here, what is the inside of the absolute value? In this case, x plus 7 is the inside of the absolute value. In this case, x minus 2 is the inside of absolute value. So critical points are the points where the inside of this becomes 0. So for example, in this case, x plus 7 becomes 0, which means x is equal to minus 7. So this is a critical value, critical point, I mean. So x equal to minus 7 is one critical point. Now we have to consider the equation number 2. So in the equation number 2, x minus 2 equal to 0. So the second critical point which we get is x equal to 2. Okay, so if you draw the quadratic plane now, so let's say that this is 2. I'm just drawing randomly. This is 4, this is 6, and this is, let's say, 2, negative 2, negative 4, negative 6, and negative 8. Okay, so now what we have established, what points we have established? So we have established negative 7 as one of the critical points. So this is negative 7. And second is this one, which is a positive of 2. So we have three intervals which are there. So first interval is, so let me write it first. So this point is negative 7. This point is positive of 2. So what are the three intervals? One interval is from here to here, okay, and which is represented as this 2. Another interval is, it is less than minus 7. So minus 7 to infinity. So if I don't want to draw it. So if we go this side, this is this interval where x is less than negative 7. And the third interval is x is greater than 2. Okay, greater than 2. So this is the three intervals which we have found here. Okay, x is greater than or equal to 2, x is less than minus 7, and x between minus 7 and 2. Okay, so three intervals, two critical points, and thereby three intervals we identified. Now after this, what we have to do? So one question which may come is, when I was writing the intervals, so how did I choose the interval? Why this was x is less than minus 7 was, I had not written x is less than equal to minus 7. I could have written the interval like this also, x is less than equal to minus 7, and in here I could have written minus 7, and here I would have, instead of less than equal to, I could have written only less than, and here I could have written less than equal to 2. Okay, this interval number 2 I could have written like this, and interval 3 I would have written like x is greater than 2. Okay, so this is also one way I could have written, wherein the the sign here equal to sign is not here, instead it is this side. Okay, or equal to sign is here. So here is a equal to sign, this equal to sign is not there, or this equal to sign is not there. So this is another way I could have written the equation, but remember that this we cannot do. So what we have to do is, whenever there is a greater than, x is greater than something, that's where you have to put equal to. When you are creating the intervals, when it is greater than, okay, here x is greater than minus 7. So with the greater than, you put a equal to here. Same here, x is greater than 2. So put a equal to here. See, the definition of the absolute function, which you would have seen, contains this thing that if you see here, so absolute value of x is x if x is greater than equal to 0. So with the greater than, whenever greater than is coming in the interval, put the equal to there. Okay, not on the less than. Don't put less than equal to. Put greater than equal to. So when you are creating the intervals, wherever there is a greater than sign for x, there you put the equal to sign. So we have to take those intervals one by one. The first interval was x is less than -7. So if x is less than -7, then definitely this is x is less than -7. So x plus 7 would be a negative value. So what would be x plus 7? It would be a negative value. So if it is a negative value, we know the absolute value of a negative value is negative of that value. Okay, for this reason, because we have to understand this concept, why this negative sign is coming here. If you have not understood, please see the video which is there in the description. Okay, so because this part is less than 0, thereby for the absolute value we have to put a negative of negative. X plus 7 is a negative, so we have to put a negative here, so it becomes positive. So absolute value of x plus 7 will be negative of x plus 7 when x plus 7 is less than 0. Same, now consider x as less than -7, consider a value -8. So -8 minus 2 would be -10. So that is also less than 0. So this is also less than 0. So it would also retain this negative sign, negative of x minus 2. Okay. Now replacing these in the with the absolute value. So it becomes minus x plus 7 minus, and this becomes minus x minus 2 equal to x minus 3. So this is our equation after putting the proper values. So now if you resolve this equation, you get a value of x equal to minus 2. So this x equal to minus 2, our case was, if you remember, our case was x is less than -7. This was the case. Okay, this was our case. Now x equal to minus 2 does not satisfy this case. So because minus 2 is bigger than -7. So it is not less than -7. So this value which has come after evaluation is not satisfying this condition. So this is not a valid value. Okay, so let's go to the other interval in the domain. So this was the second interval which we had. Here, if you consider any value between -7 and 2, if you say 7 itself, then x plus 7 and consider -7, then it will become 0. So 0 equal to 0. Okay, or consider a -7 here and it will be a negative value here. So in this case, x minus 2 will be less than 0, and in this case, it will be greater than or equal to 0. So for greater than or equal to 0, the value remains the same, and for less than, we have to put a negative value in front of the value. This we already know. And when we solve this equation, we get x is equal to -8. Again, see this -8, it does not fit this interval which we had chosen for this case. Because it does not fit this interval, so this is also a invalid value. Now let's see our third interval. So this was the third interval where x is greater than or equal to 2. Okay, if x is greater than or equal to 2, then this value would be greater than 0. So which means that this will be retaining the same sign. There wouldn't be any sign change which would be there. Same for this also. This is greater than or equal to 0. So absolute value will retain the sign. So when you solve this, you put these values and solve this, x comes as 12. Okay, and x comes as 12, and 12 is greater than or equal to 2. 12 is definitely greater than 2. So this value is a valid value. Okay, so it is a valid value. Hence, the solution of this is x equal to 12. For this equation, solution is x is equal to 12. Okay, uh, and you can solve it also and you will get the same values. If you have a 12 here, 12 plus 7 is 19. So this will become a 19 and this will become 12 minus 2, 10. So minus 10 equal to 12 minus 3. So 12 minus 3 is also 9. So both sides are 9. Okay, and let's see it with the help of a graph as well. So if you see the graph, uh, so this is this graph on the left hand side, and this is indicated with the green line. So this is this graph. Okay, and this is one critical point and this is another critical point, and this is the other graph, which is x minus 3, y equal to x minus 3. And where these graphs are meeting, they are meeting at a point which is x equal to 12. If you see here, this value is x equal to 12. Okay, thank you.